The Vixen 21, the newest entry in the motorhome and recreational vehicle industry, is expected to have a major impact on this industry as production begins in early 1986. Its sleek and stylish aerodynamic design is certainly an appealing feature of the Vixen 21. But its most dramatic feature is the mileage goals of 24 miles per gallon with its gasoline-powered engine and over 30 miles per gallon with its diesel-powered engine. Couple this with a fully equipped price under $30,000, and the Vixen will revolutionize the motorhome industry. Its 21-foot length and overall height of 6 foot 4 inches allows it to fit nicely into most residential garages. A 60-inch by 140-inch hinged panel can be raised, allowing 6 feet 6 inches of headroom over the aisleways when parked. The exterior body shell is made of fiberglass, enabling the Vixen 21 to have a curb weight of 5,100 pounds. Its sleek design yields an aerodynamic drag coefficient that is less than most passenger cars. State-of-the-art computer-aided engineering testing techniques were used in the verification of the Vixen prototype. Operational testing and modal analysis were performed by Structural Kinematics, an engineering consulting firm from Troy, Michigan. Structural Kinematics is a recognized leader in the areas of modal analysis and dynamics analysis software. The first step in the prototype testing was to measure operational data as the vehicle was driven over both rough and smooth road surfaces. These tests were conducted to identify what modes are excited on the various road surfaces and to determine the frequency range that the modal analysis testing would be investigating. 2 primary frequencies were observed during operation, one at 12 hertz and one at 37 hertz. At the conclusion of the operating tests, a modal survey was performed on the Vixen. Controlled artificial excitation was induced into the vehicle at 4 frame locations using electromechanical shakers. The response to this excitation was measured in 3 directions at 126 locations on the Vixen to sufficiently describe the structure for the modal analysis. 10 modes of interest were found in the 10 hertz to 38 hertz frequency range, with the primary frequencies of 12 and 37 hertz matching those measured in the operating tests. By displaying some of these modes of vibration and exaggerating the motion, a number of concerns can be seen. At 12.1 hertz, there is significant deformation of the panel at the driver's door. By blowing up the animated display, movement of this panel visibly shows the weakness in this area. Likewise, a potential problem associated with bending in the steering column occurs at 32.7 hertz. Additional areas of concern are the torsional motion of the rear frame relative to the body, and the response of the floor at the 12 and 37 hertz frequencies. Obviously, the manufacturer would like to implement modifications in the next level of the prototype stage that would yield optimum results in a timely and cost-effective manner. The Structural Kinematics Dynamics Analysis System has a sensitivity analysis package, which determines which areas of the vehicle are most sensitive to structural changes. The system also has modification software, which enables SK engineers to analytically try various modifications very quickly and inexpensively in the computer before any are actually made in hardware. An important feature of these packages is the ability to see how these changes affect the vehicle at other locations and other frequencies, thereby avoiding chasing the problem to a different area or causing new problems at other frequencies. Here you can see the effect of adding stiffness to the steering column by the addition of a supporting bracket. The software package allows us to place the bracket in the optimum location to eliminate the motion at the problem frequency. Likewise, the modification to add stiffness to the driver's door panel can be evaluated. These changes can now be made to the next prototype with the confidence that they will demonstrate improvement in the structural integrity of the vehicle. The Vixen 21 is an excellent example of innovative design coupled with advanced test and analysis techniques to bring a new, higher quality product to the marketplace in a compressed time frame. The Vixen Motor Company and Structural Kinematics Corporation, pioneering new paths to be leaders in their fields.